Student, today we will learn about timers and counters of 8051. So you know very well 8051 has two timers, timer 0 and timer 1, 16-bit timers. So what is the use of timers? Generally timers are used to produce the delays, and it is used to provide the frequency for serial communication. So serial communication required a fixed frequency rate. This is also produced by the timers. So delays can be produced by software loops also, but when we use the software loops, CPU time is required to execute the software loops. To avoid CPU time utilization, we can use the timers as a hardware timers. Now we will see special function registers of timers. We have T-mode, T-con registers, T0 and T1 registers. These are the four special function registers are there. So first we will see T0 and T1. T0 is related to the timer 0 and T1 is related to the timer 1. So these are the 16-bit registers can be divided into two parts, TL0 plus TH0 and TH1 and TL1. So T0 can be divided into two parts, 8-bit plus 8-bit. T1 also can be divided into 8-bit, TH1 and TL1. So next special function register is T-con, timer control special function register. It is a 8-bit register and it has TF1, TR1, TF0, TR0. These are the 4 bits are related to the timers, and next 4 bits are related to the interrupts. Now we will see the TF1 first. So TF1 nothing but timer 1 overflow flag. What is the TF1? So whenever we are working with the timers, we have to store some number into the timer to get some specified delay. So let us take one example. I have loaded 2367H into a timer 1. Then when I loaded a number, I have to run the timer with the help of TR1. So after running the timer, it will count up from the specified number to all Fs. Then immediately it will become all zeros. Whenever timer reaches its count as all zeros, then TF1 bit is automatically set as a 1. So TF1 became 1 means timer reached its specified number to all zeros. So whenever timer reaches its count as all zeros, it has to send the interrupt to the microcontroller. So by setting TF1 is equal to 1, the timer can send its interrupt. So whenever CPU got TF1 is equal to 1 means timer gives specified delay. And next one TR1. TR1 means timer 1 run control bit. After loading the number into the timer, you have to use this bit to run the timer. So by setting TR1 is equal to 1 means you are running the timer 1. Then TF0 and TR0. These two bits are related to the timer 0. They are working similar to TF1 and TR1 to show the timer 0 overflow flag and to run the timer 0. Next coming to the IE1. IE1 bit is used to know the whether external interrupt received by the microcontroller or not. If IE1 is equal to 1 means microcontroller received the external interrupt from the INT1 pin. So what is INT1 and INT0? These two pins are there with the pin diagram of 8051, and you can attach two external devices to these two pins. So whenever INT1 pin is attached to the external device, if external device is generated interrupt, then IE1 will become 1 automatically. So by seeing IE1 is equal to 1 means microcontroller got interrupt from the INT1 pin. And what is IT1? IT nothing but interrupt type. So here we can specify what type of signal you are sending as an interrupt. If INT1 is equal to 1 means you are using edge triggering signal type. If INT1 is equal to 0, you are using level triggering signal type. So next take one next bit IE0 and IT0. These are the two bits are related to the INT0 pin. So whatever external device you connected to the INT0 pin, so that device can send the interrupt to the microcontroller. So whenever interrupt is generated by that device, IE0 will become 1 automatically. So like this, microcontroller can see whether interrupts are generated by the external devices or not. It can see. Here TCON register is bit addressable register, means you can access single bit or you can access total byte also. So you can use one bit in your program. So next special function register is T mode, timer mode register. Using this register you can select the timer mode. Here 8051 has 2 timers and 2 timers has 4 different modes, mode 0 to mode 3. So you can select any mode of timer and you can work with that mode. See here, first 4 bits are related to the timer 1, next 4 bits are related to the timer 0. So these first 4 bits are same as next 4 bits. So first we will see the gate bit. Gate bit is used to specify what type of control you are using with the interrupt, hardware control or software control. If gate is 1, you are going to use hardware to control the interrupts. If gate is 0, you are going to use software to control the interrupts. That is the gate. Then C by T bar. C means counter, T means timer. So C by T bar is equal to 1 means you are selected counter. If C by T bar is equal to 0, you are selected the timer. If it is 1, counter. If it is 0, timer. Next is M1 and M0. These are the 2 bits are used to select the mode of the timer. So just look at this table. If M1 and M0 is 0, 0, you are selecting mode 0. What is a mode 0 timer? 13-bit timer. You know very well the timers are 16-bit timers, but if you selected mode 0, you are working with only 13-bit timer. Then 0, 1, you are selecting mode 1, and here 16-bit timers you are using. X10 mode 2 auto reload mode timer you are using. Then 11 mode 3 2 8-bit timers of timer 0 only. So here the timer 0 is divided into 2 parts, that is nothing but 2 8-bit timers. So this is about T mode, which is used to select the mode of the timer, and are you working with the counter or timer? According to that you can select the C by T bar. Now we will see the design of the timer modes. So look at this diagram. It is a timer mode 0. So it can be any timer, timer 1 or 0. So TLX, X means here 0 or 1. So TL0 or TR1. So you are using mode 0, nothing but 13-bit timer. So 5 bits from the lower byte of the timer and 8 bits from the higher byte of the timer. So together 5 plus 8, 13-bit timer you are using. So you will load one number into this timer and it counts up. Whenever it reaches all zeros, it generates the interrupt by setting the TF1 or TF0 equal to 1. So this is the flag you are going to use to generate the interrupt. The interrupt is given to the microcontroller. Next, mode 1. Look at this diagram. Mode 1, nothing but 16-bit timer. You have to utilize full 8-bit of lower byte and higher byte. 8 plus 8, nothing but 16-bit timer is used. And TFX means it may be TF0 or TF1 timer overflow flag to generate the interrupt. Next, coming to the mode 2. Mode 2 timer, nothing but auto reload mode timer. This is a 8-bit timer. Only 8-bit timer you can utilize in the auto reload mode. So first you have to utilize only TH. It may be TH1 or TH0 of timer 0 or timer 1. You have to utilize only higher byte to load the number. First load the 8-bit number into the TH1 or 0. Then run the timer. The number is loaded into the lower byte and it will count up. Whenever it reaches to all zeros, then it will generate the interrupts. So remember, auto reload mode timer, nothing but only 8-bit timer, and that too you have to use higher byte in your program. Then next come to the mode 3. Mode 3, nothing but 2 8-bit timers of timer 0 only. So under mode 3, timer 0 will work. Timer 1 cannot work. So see this TL0 and TH0. These are the 2 8-bit timers of timer 0, and you can run these timers with the help of TR0. The first TL0 runs with the TR0, TH0 will runs with the TR1. So using these run control bits, you can use the 8-bit timers, and whenever they reaches to the count as all zeros, J interrupt is generated.